Bismillahirrahmanirrahim. In this video, we'll talk about general second order circuit, which is part of linear circuit analysis. Now, before we start, let's just recall from my previous lecture the concept of time. So this is the time 0, t is equal to 0. And just slightly before, maybe nanoseconds earlier, we call it time t0 minus. And similarly, maybe a nanoseconds later, this time we call it t0 positive. So keep this point in mind. Along with this, you have to keep in mind that the capacitor voltage does not change instantaneously, that the capacitor voltage always continues, so that V0 plus is equal to V0 minus. So whatever is the capacitor voltage here, same will be the capacitor voltage here. Same way, the inductor current does not change. So the inductor current at this point will be same at this point. Keep in mind also that when we say I, we mean I inductor, and we just say V, that means we mean it is V capacitor, voltage capacitor. Okay, now if you recall from the previous videos, the step response of a series RLC circuit, this was the circuit, and its answer was that the total response is given by the transient response plus the steady state response. And this was the second order circuit from which we obtained the result. Similarly, the step response of a parallel RLC circuit, we had a second order differential equation, and we found the total response, in this case current. So IT total response is I transient plus I steady state. So we just follow these patterns, but here the question is, other than the series circuit and parallel circuits, there are possibilities of other circuits, of second order circuit like this one. So this is series parallel, we can say. The inductor is in series and capacitor comes in parallel. There are two energy storage source, capacitor, inductor and capacitor. Therefore, this is a second order circuit. Similarly, here we have two inductors. So this is also a second order circuit. So how do we solve these circuits? So for this type of a circuit, which are neither series nor parallel, we use the second order circuit procedure. Okay. One more thing. Previously, when we were saying step response, that means we applied a voltage suddenly. The switch was closed, and before it was 0, suddenly it becomes 12 volt, and the capacitor took time to charge. So this period is called the transient period. So the moment we apply the step voltage, the circuit went into transient mode. Now, very interesting, what will happen if we remove the source? So this is the circuit, and suddenly we remove the source, make it 0, then it will be something like this. 9 volt, it was 9 volt previously, suddenly it becomes 0. So this is also going to take the circuit into the transient mode, and the voltage will now gradually reduce. So this is also in transient mode. So this technique we'll be using in this case, that is, by removing the source, we'll go into the transient mode. Okay, as I have been following the steps in case of a series circuit and parallel circuit, same steps I'll be following, similar steps rather, with minor differences, changes. So these 7 steps we'll follow, and we'll go one by one to solve the problem. Another important point we have to keep in mind that when we say t less than 0, then primarily we are somewhere here. When we say t greater than 0, then after we have gone over this period, that is t0 minus and t0 plus, then starts the transient period. So when t becomes greater than 0, then the transient period starts, and finally when the circuit becomes stable, then is the t infinity, or the final value, or steady state value. Okay, so now let's apply whatever we have learned to solve this problem. This is example 8.9, so I'll just highlight some of the things which are slightly difficult to understand. So for this circuit, this is the circuit, we have to find the final value or the complete response of voltage and complete response of current for t greater than 0. So the first step, for t less than 0, we have to find the initial conditions, that is I0 and V0. Now t less than 0 means this switch is not closed. So let's draw the circuit. So this is not closed. Circuit is in a steady state. Therefore, the inductor is short and the capacitor is open. Now this is for much earlier time till t0 minus. Okay, so from here if you see what is the voltage here, this voltage, you see 12 volt flowing and there is no outlet, circuit is not complete, so this is open. So we know that in case of an open, the source voltage will appear. So we can say that V0, or we can draw the circuit slightly neatly, same circuit. So V is 12, or V0 is 12 volt. So we write V0 or V0 minus. V0 minus we'll call it, is 12 volt, and since no current is flowing, therefore I0 minus will be 0 volt. 0 ampere. Okay, now we are in step number 2. Step number 2, we have to find dV0 dt, and which is equal to actually IC0 over C. And similarly, if we have to find di0 dt, then we need it is VL0 over L. So that means we have to find IC0 for this case, and we have to find VL0 for this case. Now keep in mind, I have highlighted it in red, that the circuit must be in the transient circuit mode, transient mode. That means the switch is closed, but capacitor and inductors, they remain there. Inductor will not be short and capacitor will not be open because the circuit is in transient mode. So our circuit will become like this. The switch is closed and no change in the inductor or capacitors. And by continuity of the capacitor voltage and inductor current, we know that the voltage at V minus will be same as voltage at 0 plus, and which was 12 volt. Similarly, we know that current at I0 minus is equal to current at I0 plus, which was 0. So we got these two conditions for V0 and I0 plus. Okay. Now we work on this mode because we actually need to find IC for this. So at this, if we write KCL equation, so current entering is current leaving and current leaving. So we can say I is equal to IC plus IR. I is IC plus IR. And now in terms of a voltage, or in terms of, what you call positive at time, 0 positive, So I will become I0 positive, IC will become IC positive, and IR will become V0 positive over 2, because this is what V over 2. So for T0 we'll write V0 positive over 2. And now I0 is 0. We know from here I0 positive is 0. IC we have to find. V0 positive was 12. So putting that value. So from here we find IC0 is equal to minus 6 ampere. Okay, now we need to find the dV/dt terms. So for this we know that IC is C dV/dt, and from here we will see that dV/dt is equal to IC over C, and therefore for t greater than 0 it will become dV0 dt is equal to IC0 plus over C. Now IC0 plus is minus 6 from here, and C from here, if you see, it is minus 5. So solving, we find dV0 plus dt is minus 12 volts per second. Okay, step number 3. Next we obtain the transient response for t greater than 0 by turning off the source. As I had explained, that when we turn off the source, the circuit goes to transient. So that is what we'll do. And voltage source, when we short circuit, this is turned off. So our circuit will become like this, neatly drawn. It is shown here. Now from this we'll get the second degree equation, characteristics equation, and roots. Let's see how to proceed. Applying KCL at node A. So we are here at node A. KCL again, current entering I and current going into these two paths. So I is equal to, now this current IR is V over 2. So we write it V over 2. And IC is, we know IC is half, that is C dV/dt. So C dV/dt, that is 1 over 2 dV/dt. So that is one equation. The other equation we can find from the left mesh by KVL. So we can write it as 4I plus, now this is voltage, we know VL is L di dt. So we can write it as 1 di dt and plus this voltage here V. So plus V is equal to 0. I hope you can follow how to write KVL, this one. Okay, so now since we are interested in V, we need to find the answer. First of all, we need to find V. So we'll substitute I from equation 894, from here I in this equation. So what will happen? 4I, so 4 into the value of I from here, plus 1 di dt or dt, and again I, this value, plus V equal to 0, and we can follow the steps, simplify, and from this we obtain the characteristics equation. So now this is a second degree equation. So substituting by S, this will become S square, this becomes 5S, and this becomes simple 6. So S square plus 5S plus 6 is equal to 0 becomes our characteristics equation. And from here we can see that the roots are, this can be written as S plus 2 and 3S plus 6. So from here we get these two roots. S1 is equal to minus 2 and S2 is equal to minus 3. Okay, now we get the natural response. We have the two roots, so we can write the natural response. This formula we'll use. V natural is AE power S1t plus B e power S2t, and putting in the value of S1 and S2. So this is the natural response. But we need to find, and here A and B are unknown, so we'll find A and B later on. Okay. Then we'll obtain the final value, because in the complete solution we need to have a final value. So final value of I or V we need to find. Now in the final value, what will happen to the circuit? Now the inductor will become short circuit and the capacitor will become open circuit, and we have to find this voltage V. So this is the circuit we have. So we can find the VSS, that is steady state, which is also called V infinity, is total voltage divided by total resistance multiplied by 2. Total voltage divided by 4 plus 2 multiplied by 2 is 4 volt. So this is the steady state voltage. And now we are ready to find the complete solution. Complete solution we know is the transient plus a steady state for voltage, and similarly for current. So let's see, in this case the complete response will be Vt is V transient plus VSS. VSS is 4 from here, and this was the transient response that we got from here. So this is our complete response, but we have to find the value of A and B. So let's proceed. Complete response. Now we need to determine AB using the initial values. So what we'll do is we'll put t is equal to 0 in this equation. That t is equal to 0, this becomes V0, 4, this will become A, and this will become B, because e raised to the power 0 is 1. Okay. Now V0 positive, V0 negative was 12, so we'll plug in this value here. So 12 is equal to 4AB, or A plus B is equal to 8. So this is one equation. Now to get the other equation, we have to differentiate this, as we have been doing in case of a series circuit, parallel circuit as well. So we take the derivative of V, and taking derivative of this, we get minus 2a e raised to the power minus 2t and minus 3b e raised to the power minus 3. And now we put 0, t is equal to 0. So this will become dv0 dt, and from here we get minus 2a, and from here we get minus 3b. Now remember, we had also calculated this value in the first step, or second step, I guess. So this we had found to be minus 12 volts per second. So we'll plug in that value here. So putting in that value, we get second equation, which is 2a plus 3b is equal to 12. And now we'll solve. So these were the two equations that we got. And from here, we can find a to be 12 and b to be minus 4. So I hope you can solve this. And now we put these values into the complete solution. So the complete solution will now, this one, this was the solution that we had got. So we'll plug in for A is 12, and for B we'll plug in minus 4. So this is the final equation for voltage. Now the question he has asked to also find the final equation for current. So to obtain I, we know this was the formula for I. So I'll just plug in this value for V. So this term, putting in the value here, divided by 2, and half d and of v. So differentiating and solving, this will become the first part, and this after differentiation will become this, and so simplifying, this is the final answer for current. So I hope this gives you an understanding as to how to solve this type of a problem. Slightly lengthy, but if you go step by step, you cannot make mistakes. Thank you.